Hi everyone, it's Mrs. Renner. I'm going to do the solutions for wave problems number 2 now. All right, so we are looking for the wavelength. This is what is a wavelength of a wave that has velocity of 3 meters per second and a frequency of 20 hertz. So we need to translate this into variables. When you look at your table of friends, you see that wavelength has the variable lambda. So we say, what is that? Lambda equals question mark. The velocity, another word is speed. So when you see speed of 3 meters per second, you can see what the variable is, and you can see the variable is v. So we write v equals 3 meters per second. Lastly, we have 20 hertz, right? You see that's a frequency, it says frequency, but if you just even looked at the units, you look at that table of friends, you find hertz under the units, and you say, what variable is that? And you say, hey, it's F. So there we are. So now we need to look at our triangle. F lambda. I guess sometimes I have that. So what are we looking for? We are looking for lambda. Okay, so I'm going to cover that up. And what do I have left? I have v over f. So I'm going to write my equation in variables. V over f. I need all of these things to get full credit. All right, now I'm ready to plug in some numbers. So I can write lambda equals, so instead of v, I'm going to write 3 meters per second. And instead of f, I'm going to write 20 hertz. Now I'm going to take my handy dandy calculator. I'm going to do 3 divided by 20, and I see that that's 0.15. And then my units, meters per second divided by hertz. My gosh, that's ugly. But if I look at my table of friends, I see that my variable lambda, which is wavelength, matches up with the unit of meters, and I can see I had 3 meters per second. There's that meter just waiting for you. All right, that's number 1. All right, number 2 asks us for the frequency. What is the frequency of a wave that has a velocity of 15 meters per second and a wavelength of, oh, that could have been nicer the way I could have written that. Sorry about that. 7 meters. Okay, so frequency, it has the variable f, so f equals question mark. My 15 meters per second, right? My trick is looking at the units, meters per second, looking at my table of friends and saying, oh, that matches up with the variable v. And then my wavelength of 7 meters, that has the variable lambda. So in order to get the correct equation, I need to use my triangle. I'm going to cover up f, and I end up with f equals v over lambda. So, good. That's my equation in variables before I plug in the numbers. And then my v, I can plug in 15 meters per second. Don't forget those units in your equation. 15 meters per second divided by 7 meters. Well, 15 divided by 7, I believe, is nothing pretty. It's like 2.14, and there's lots of more numbers, but I'm not going to write them all down. I just want to do 2-3 decimal places. So 2.14, and then what are our units? Well, we're looking for a frequency, and I know that frequency has units of hertz. There we go. Alrighty, now we have a wave that travels with a speed of 500 meters per second and a wavelength of 10 meters, and we need to find out its frequency. So v is equal to 500 meters per second, that's the speed. My 10 meters matches up with the variable lambda for wavelength. And, oopsie, forgot to put a box around that. And my frequency, which has a variable f, is, that's what you're looking for. So You probably know what the equation is already. Whee! F equals V over lambda. So that's 500 meters per second divided by 10 meters. So that number is 50. And the unit is meters per second over meter. But guess what? It ends up being 1 over second. And I know that frequency is measured in hertz. All right, here's our fourth question. If a wave has a frequency of 34 hertz and a speed 340 meters per second, what is the wavelength? So my F is equal to 34 hertz. My V is 340 meters per second. And we're looking for the wavelength. And go away, lambda. What you got? V over F? Okay. Lambda equals V over F. 340 meters per second divided by 34 hertz. Hey, 340 divided by 34, that's pretty nice. That's 10. And what are our units? Our units are whatever the units for lambda should be. So we've been dealing with meters, seconds, hertz. Okay. And it is meters. There we go. And finally, we have our last problem. This one asks, oopsies. This one asks for the speed of the wave if its frequency is 74 hertz and its wavelength is 6.5 meters. So here it's asking for V, just like old times. Our F is equal to 74 hertz and our wavelength lambda is 6.5 meters. Well, here's my handy dandy triangle. I want to solve for V, so I get V equals F lambda, which you probably knew already. All right, F is 74 hertz, lambda 6.5 meters. When I do that in my calculator, I get 481. Well, what units does V have? Meters per second. And that's all she wrote.